All right, so first I'm going to do the ones that I did in class today with the students, and then I'm going to go back and do the rest. So if you're just looking for the in-class notes that you missed, you can watch the first part of this video. If you're looking for doing extra practice problems, then you can watch the end of the video. All right, we're starting on number 1, where we're being asked to graph the inverse of this linear function. So because it's a line, because it is a linear function, we're able to graph at least or just 2 points, meaning with 2 points, we have a line. We don't need more than that. So that's nice because it's linear. So let's go ahead and just get 2 points for this line. And what 2 points are nice and easy to get? Well, let's go get the x and y intercept. In Math 1, you guys learned how to get an x-intercept. For the x-intercept, the y is 0. And then for the y-intercept, the x is 0. So let's go plug in 0 and get those values. We're going to say this is the x-intercept. We're going to say 0 is equal to 2x plus 4, and then we're going to solve backwards for x. And so again, this is a Math 1 skill, being able to plug in 0 for the output and find the x-intercept. We're getting that the x-intercept is -2. For the x-intercept, the y is 0. We write it as -2, 0. Now let's go do the other. For the y-intercept, the x is 0. We're this time going to plug in 0 for x. So y equals 4. So my y-intercept is 0, 4. So we're going to go put these 2 dots in the graph now. Now remember, back to the beginning of the semester, anytime we're doing a graph, or even back to Math 1, we're going to label and scale our x and our y. And I'm going to scale this. Let's just count 1, 2, 3, 4, 5, 6, 7, 8. These are just out 8, 8, -8, -8. Make sure you're scaling right on the line if you're planning to go to Math 3. You want to be precise. Let's go put those 2 dots, -2, 0. I'm going to go ahead and use pink for my first line. There's my first intercept. And then let's go put the second dot at 0, 4. Now I'm going to go grab the line function here and see if I can connect these two. Oops. And there's my arrows. So this is the graph of my original function f of x. So go ahead and label that red line f of x. Now, every inverse is a reflection over the same line of reflection. The line of reflection I'm talking about is y equals x. So let's get that line of reflection on there. How do I graph that dot? I'm going to start at the origin and then just go up 1 over 1, up 1 over 1, the whole way across, and down 1, back 1. Let's go connect that with our line function. And technically, I've been drawing that in class as a dashed line because it's not my inverse, it's not my original function, it's just our line of reflection, but I'm just going to connect it as a solid line here for the purposes of that I'm going digital. So there's my line of reflection. My red line is going to reflect over that to make the inverse. Well, to go make the inverse, I need 2 dots. So what 2 dots do I have? I have the x and y intercept of the other graph. So I'm going to go and flip those dots. My x is a -2, my y is a 0. If I flip that, it becomes 0, -2. It's my new y-intercept. What was once an x-intercept is now a y-intercept. Let's go flip the other one, 4, 0. What was once my y-intercept is now my x-intercept. So let's go put those dots on the graph. 4, 0, 0, -2. I'm going to go grab my line function. And here comes my line, which is an exact reflection. The red line has now been reflected over the line of reflection. Remember that we always have to label. So we're going to make this f of -1 of x. There's my inverse function. So how did I graph this? To graph the linear equation, I needed 2 dots. So I used the intercepts. This is my Math 1 calculation work for getting the intercepts. Then I flipped those dots to get the 2 dots of my inverse. And I graphed it. Don't forget to always do a line of reflection on every inverse graph. Now we're just left with writing this equation up here. Remember that there's a couple ways to write this equation. Let's talk about the graphs of these lines and these equations. The red line, maybe you didn't need these 2 dots to do the red line. Maybe you looked at this graph and you could see that the slope was 2, and you could see that the y-intercept, or the b, was 4. So you were like, yeah, it begins at 4 and it goes up 2 over 1, down 2, back 1. You could see that that was going to be the graph of the line from the slope-intercept form. Or maybe you just thought of inputs and outputs. Like, what if I plugged in 1 for x? F of 1 equals 2 times 1 would be 2. 2 plus 4 is 6. I could go put a dot at 1, 6. Okay, maybe you thought of it as inputs and outputs. There's lots of ways to graph. Now let's look at the blue line. I need the equation for this blue line. If I want the equation, couldn't I technically just get the y-intercept? Okay, it's down 2. And couldn't I just count the slope? The slope this time is up 1 over 2, up 1 over 2. So using slope-intercept form, I could just plug in that slope of 1/2, and I could just plug in that intercept, and there's the equation of my line. This is the equation of my blue line, my inverse. Well, some of you may not be able to do that. You might go, oh, I'm not good at coming up with an equation for that. So we have the shortcut rule. We can go do our quick little table and come up with the equation of the inverse quickly. So I'm going to go f of x, f of -1 of x, and let's go talk about what's happening to the original function. The original function is 2x plus 4. What's happening first to the x? If I plugged in a number for x, 2 times 1, 2 is multiplying by the x first, and then 4 is being added last. So swooping around, we're going to do the opposite operations now. We're going to be minusing 4 and dividing by 2. Or as we talked about in class, instead of saying divided by 2, we could say times 1/2. So now I'm going to go write my equation based on these operations of minusing 4 and dividing by 2. Here it comes. Start with your base of x. We're going to start by minusing 4 and then dividing by 2. And that's my equation. But if you don't want to write it divided by 2, like we talked about in class, you could just put the 1/2 out front. Now let's look at my original that I just talked about. Do you see how this equation that I just got from the shortcut table is the same as this equation, meaning if I distributed it 1/2 times x, 1/2 of -4, they are equal. So which way did you like? Your choice. Do you want to write the equation just straight off the blue line like this? Or do you want to write the inverse based on the table shortcut that we did? Or do you want to do the full work for the inverse? It's up to you. So this is the work we did in class on number 1. We then scrolled down and we did number 2C. So this one is not just a linear equation. It's technically 2 linear equations together, right? It's like got an elbow here. It's got one line going one way and another line going another way. So I need to make a table this time. I'm going to make a table of values. And then the definition of inverse is that we're going to flip those values. So you guys need to go get me some dots. What is this dot? What is this dot? What is this dot? Etc. And pause the video right now, please, and go get those coordinate pairs. All right, how'd you do? The first dot is back 1, 2, 3, 4, 5, and down 4. Second dot is back 4 down 1. Third dot is back 3 up 2. Fourth dot is out 1 up 3. And last dot is out 1, 2, 3, 4, 5 up 4. Okay, those are my coordinate pairs of the f of x function. We now want to flip these coordinate pairs and get the inverse function dots so I can go graph my inverse function. Okay, so taking the negative 5, 4, it's now going to become negative 4, negative 5. Taking the negative 4, 1, it becomes 1, negative 4. Taking the negative 3, 2, it becomes 2, negative 3. This becomes 3, 1. This becomes 4, 5. Notice that I just completely switched the x and y values. I did not change any signs or do anything weird. These are my new dots of f of negative 1 of x. Before I do anything, let's get that line of reflection on there. Line of reflection is going to go through the origin every single time and up at a slope of 1. There's my lore, my line of reflection through y equals x. Let's go get my line function to draw that on there. Every single inverse has the line of reflection through y equals x. Okay, I'm going to go do a blue line right now of my inverse. Remember to say out loud to yourselves, f of negative 1 of x. Try it at home. So back 4 down 5. Right here on the corner of the line. 1, negative 4. As we're drawing these dots, look at how it's an exact reflection of this guy over here. Look at how this is an exact reflection over here. 2, negative 3. I did something wrong. Hang on. Two, negative 3, and let's go to 3, 1. Oh, I see what I did right here. Sorry, guys. This is a negative 1 right here. I even think I made that mistake in class and you guys caught me. Okay, so reverse. Okay, so let's fix this again. We're going back 4 and down 5. That one was right. But this one right here is negative 1, negative 4. Now it's going to be in the right spot. And then we go 2, negative 3. Then we go 3, 1. Then we go 4, 5. So here I go with my line function. I'm going to connect this blue inverse. There's this segment of the line, and then there's this segment of the line. Look how it kind of made like a diamond, and it looks like an exact reflection over the other. Don't forget, oops, I'm still on the line function, to label it as f of negative 1 of x. There's our graph of the inverse function. Let's go to the back and do the 3 examples of the equations. How'd you do on this graph? Let's go try some equation writing last. All right. Let's do these the table way. All right, so we've got f of x being given to us, and now we're going to try to get f of negative 1 of x. Oh, let's do red. Get all 3 of your tables ready. Now, what we're looking for is what is happening to the x value, what's happening to our input, and we're going to list out those operations. And then we're going to reverse those operations. Those are the operations that would be happening in opposite order to our inverse. The undoing of one function is what creates our inverse. So what's happening to our x right here? First, it's being multiplied by a -2. So times -2. Then it's being subtracted of a 3. So here I go now. After I go down this way, I swoop around and I do the opposite. Now I'm going to be adding 3, and I'm going to be dividing by -2, or as we said in class, multiplying by -1/2. So now I go build my function. F of -1 of x equals, get that base x ready. The first thing that's happening to it is that we're adding 3, and then last we're dividing by -2. You can write it as divided by -2, or you can write it like we did in class, as times -1/2. Okay, wanted to move that over a little bit. So which way do you like to say it? Do you like to say x plus 3 divided by 2, or do you like to say -1/2 times x plus 3? It is the same equivalent equation. Okay, here we go on the next one. What's happening to the x first? X is being squared. What's happening to the x next? X is doing +5. We're going to do the opposite of that. We're going to go -5 and square root. Did you know that the opposite of squared is square root? So here I go writing my equation. F of -1 of x is equal to, start with your base of x. First, we're going to -5. Then we're going to take the square root of it all, and we're done. Finally, let's do the last one we did in class. What's happening to the x this time? First, the x is being square rooted. Then the x is having an 4 added to it. So let's swoop around and do the opposite. Now we're minusing 4. Now we're squaring it. So let's go build our function. This is our last one. Start with your base of x. We're going to do these in order from bottom to top. First, 4 is being subtracted. Then we want to square that whole quantity. And we're done. Now, that video kind of ran a little bit longer than I expected. So for the extra problems, I will be making a second video tomorrow to do those extras if you want to practice, okay? And for now, though, at least you guys have this to reference to make sure you got all the notes from class. And how do you feel like you're doing on inverses? Good job.